Hi students, welcome to physics classes. Now we are discussing 8th class IIT NEET foundation course. We have discussed about force. Some topics we discussed. Part 1. Now today we'll discuss part 2. Now the second synopsis we'll discuss about Newton's first law. Newton's first law states that an object continues to be in its state of rest or uniform motion until an external force acts on it. Means if the body is at rest, if the body is at rest, it continues to be in its state of rest. If the body moving, if the body moving, it continuously moves in uniform motion in a straight line, uniform motion in straight line path, unless we apply any external force. If we didn't apply any force, if the body is at rest, it continues to be in its state of rest. If it is moving, it moves with uniform motion in straight line until we apply any external force. If we didn't apply force, it will be continuous its state. If we apply force, it will changes its state. Next one is momentum. Momentum is the product of mass and velocity. Momentum is the product of mass and velocity. Momentum is denoted by letter P, equal to mass into velocity. Mass into velocity. Now, velocity of the body is not uniform. Initially, it will have some velocity when it is starting. After traveling some distance due to the application of force, any external force, its velocity changed to v in a time t. So velocity of the body changed. Then momentum also changes, no? That is, change in momentum equal to mass into change in velocity. Change in momentum equal to mass into change in velocity. SI unit of momentum, mass kg, velocity meter per second. CGS unit of momentum, mass gram, velocity centimeter per second. Gram centimeter per second. Now this change in momentum in a particular time, that depends on the force we apply. If you apply more force, more change in momentum in less time. If you apply less force, less change in momentum in a particular time. Next one is Newton's second law. Newton's second law states that rate of change of momentum of a body is directly proportional to force applied. What Newton's second law says, rate of change of momentum in a particular time, change in momentum is directly proportional to, means depends on force that we are applying. If more force is applied, more change in momentum in a particular time. Less force if we apply, less change in momentum in a particular time. So we can write F is directly proportional to rate of change in momentum divided by time. Change in momentum by time. So F is directly proportional to m into v minus u by t is acceleration. F is directly proportional to m into a. To remove proportionality symbol, we can take constant k equal to ma. K value is 1. So F equal to mass into acceleration. This is the formula for force. F equal to mass into acceleration. Now SI unit of force is kg meter per second square. Mass SI unit is kg. Acceleration SI unit is meter per second square. CGS unit is gram centimeter per second square. CGS unit is gram centimeter per second square. SI unit also can be written as Newton. CGS unit dyne. So 1 Newton equal to 1 kg meter per second square. 1 dyne equal to 1 gram centimeter per second square. And it is having one relation. 1 Newton equal to 10 power 5 dynes. Newton equal to 10 power 5 dynes. This is about Newton second law of motion. Here we derived formula for force and we discussed about force. Now we have two types of force. In that first one is balanced force. Balanced force means, for example, if you take an object, on that object different forces are acting. Different forces are acting. We can say set of forces acting on a body produces no acceleration. If that force is acting on the body and it is not producing any acceleration, then that forces are known as balanced forces. Set of forces acting on a body produces no acceleration, then that forces are said to be balanced. Next one is unbalanced forces. Now here in balanced forces, set of forces acting and produces no acceleration. If the body accelerates, that are unbalanced forces. Set of forces acting on a body produces non-zero acceleration, means some acceleration it is producing. Then the forces are called unbalanced forces. Next one is impulse. Impulse means if a large force acting in short interval of time, large force acting in short interval of time, large force acting in a short interval of time, then it is known as impulse. Impulse is denoted by letter J. J equal to force into time. So we can write force means m into v minus u by t into time. T gets cancelled, m into v minus u. So we can write it is change in momentum. So impulse equal to change in momentum. So impulse also have same units like momentum. Impulse units and momentum units are same. Impulse is simply change in momentum. Next, Newton's third law. Now Newton's third law states that every action has equal and opposite reaction. Every action has equal and opposite reaction. For example, if we hit the wall with a force F1, if you hit the wall with a force F1, wall also hits with a force that is F2 in opposite direction. Wall applies a force in opposite direction. We are hitting the wall. At the same time, we are also getting hurt. Means wall also hitting with the opposite force. F1 and F2 magnitudes are equal. F1 force and F2 force magnitudes are equal, but the direction is opposite. When we apply force in this direction, wall applies force in opposite direction. We have some applications related to Newton's third law. In that first one is we are able to walk. When we are walking, even we don't know Newton's third law, we are able to walk. When we are walking, there is Newton's third law. When we are going forward, means we are pushing the floor backward. When we are going forward, we are pushing the floor backward. Means when we push the floor backward, floor pushes us forward direction. When we are jumping, by standing simply we can't jump. We will bend our knees and we will push the floor, then we are able to jump. We will push the floor. When we push the floor pushes us up. So for jumping also Newton third law is there. Next, rowing a boat will push the water back, water will pushes the boat forward. Even when we are swimming or when we are running also, we will push the water. When we are swimming, we will push the water with our hands. We will push water with our hands. When we push the water backward direction, water pushes us forward direction. Even when we are running, we will use our hands in oscillatory motion. We will move our hands like this. So when we are moving like this, we will pushes the air, then we are going forward. If you hold hands like this, can we run? We can't run. Or we should move our hands. Next, very important one is launching a rocket. Now while launching any rocket, they'll release large amount of gases down. They'll release large amount of gases down. That gases hits the ground. When it hits the ground pushes the rocket upward direction. That principle of launching rocket also Newton third law. Next one is pressure. Now if a force applied on unit area, if a force applied on unit area, force acting in unit area is known as pressure. Force acting on unit area is known as pressure. Pressure is denoted by letter P, equal to force by area. Pressure equal to force by area. Now here we can change the pressure by changing the area, by changing the force. Area is constant. If area is constant, the more force you apply, that much pressure increases. If you apply less force, pressure will be less. Whenever force is constant, if you have more area, pressure will be less. Whenever you have less area, pressure will be more. Here when the area is constant, pressure is directly proportional to force. When force is constant, pressure is inversely proportional to area. Now pressure, SI unit of pressure is Newton by meter square. We can write units simply by taking the formula. Force units Newton, area units meter square. CGS units dyne centimeter square. CGS unit of force by CGS unit of area. SI unit is also known as pascals. This is about second synapsis concept. Now we will discuss some example bits. Now the question is, if no external force acts on a body, no external force is acting. If it is at rest. First option is rest. Second option is motion. Third option can't say. Fourth option, none of this. So if no external force acts on a body, if it is at rest, it will be at rest. Next, if no external force acts on a body, if the body is in motion, same options, then the answer is motion. That object also continues to be in motion. Okay. Next question. Dash is the product of mass and velocity. Product of mass and velocity is momentum. The options they can give you: first option inertia, second option force, third option momentum, fourth option acceleration. So momentum is correct answer. Next question. The rate of change of momentum is directly proportional to. It is Newton's second law. Rate of change of momentum is directly proportional to force. Force that we are applying. Next, dash is equivalent to force that produces an acceleration of 1 meter per second square of a body of mass 1 kg. Mass is 1 kg, acceleration is 1 meter per second square, then force equivalent is 1 Newton. Set of forces that produces no acceleration. No acceleration means balanced forces. Set of forces that produces acceleration. Unbalanced forces. Large force acting in short interval of time. Large force acting in short interval of time is impulse. What is the formula for impulse? J equal to F into T, or we can take it is change in momentum. Change in momentum. Next, for every action, there is an equal and opposite reaction. Equal and opposite reaction. Force acting per unit area is called pressure. Force acting in unit area is called pressure. Pressure equal to force by area. How can you increase the pressure? By keeping area constant. When area constant, pressure is directly proportional to force. When force is increased, pressure also increases. How can you increase the pressure? By keeping force constant. When force is constant, pressure is inversely proportional to area. When area decreased, pressure will be increases. Calculate the force required to produce an acceleration of 4 meter per second square in a body of mass 4 kg. Force equal to mass into acceleration. Then m they given 4, acceleration also 4, 16 Newton or 16 kg meter per second square. Next, a body of mass 3 kg moving with 6 meter per second. Calculate the momentum. Momentum equal to mass into velocity. So P equal to mass 3 kg, velocity 6 meter per second. Then 3 into 6, 18 kg meter per second. A force acts for 2 seconds on a body of mass 4 kg initially moving with 5 meter per second. Its velocity becomes 7 meter per second due to this force. Then calculate the force. F equal to m into v minus u by t. M 4 kg, v minus u 7 minus 5 by time 2. So 4 kg meter per second square or 4 newtons. Thank you for watching. Please subscribe for more updates.